Analyze the physical observation at room temperature. When H2 and O2 are mixed at 25 degrees Celsius, no reaction is observed. This indicates that the rate of the reaction under these conditions is virtually zero, which is a kinetic property rather than a thermodynamic one. Analyze the effect of the spark. Introducing a spark provides a localized source of high-energy heat. This input allows the gases to begin reacting vigorously, releasing a massive amount of thermal energy. Once started, this exothermic reaction is self-sustaining because the heat released by the reacting molecules provides the energy needed for neighboring molecules to react. Relate the initiation barrier to collision theory. According to collision theory, for a chemical reaction to occur, reactant molecules must collide with sufficient kinetic energy to overcome a minimum energy barrier, known as the activation energy, EA, which is required to break the strong H and O equals O covalent bonds in the reactants. At 25 degrees Celsius, the average kinetic energy of the gas molecules is far too low to overcome this barrier. The fraction of collisions that possess enough energy to successfully react is negligible, leaving the mixture kinetically stable or trapped. The spark provides the necessary localized kinetic energy to help the initial group of reactant molecules surmount this activation energy barrier. Identify the matching option. The necessity of an initial energy source, the spark, to kickstart a highly favorable exothermic reaction is due to a large activation energy at 25 degrees Celsius. This directly matches option D. The correct answer is option D. The reaction has a large activation energy at 25 degrees Celsius.